Okay, let us continue with the third part of the lecture, which is an overview or a shallow dive of Hadoop. So in the previous part, we had discussed what a big data cluster looks like and what are the various things that you need to worry about when managing a big data cluster and how that you do not have to do it. There are open source ready-made solutions available for this. And one of the most popular ones is Hadoop. So one way to think of Hadoop is to think of it as an operating system for big data. So to better appreciate this sentence, we need to understand what is an operating system. Well, the operating system is the primary software that you install on your hardware. When I say primary, it means if you want your monitor to flicker, it is the operating system which will give you the APIs, the interfaces by which you can interact with the monitor. If you want your computer to generate a sound, then the operating system is responsible for giving you a way of conveying your intent that a sound should be produced. Similarly, for transferring data on a network, writing your data on a USB drive, writing your data on a hard disk. The OS is the primary software which helps you interact with the hardware. And every application that you write hardly communicates with the hardware, it directly communicates with the OS instead. And the OS will eventually make the hardware do what your application should do. Which is why, if you have noticed, some software only works on some operating systems because the person who has developed the software has designed it only for a particular operating system. So as I was saying, Hadoop is an operating system for big data and it is made up of multiple machines. So the idea is that you want to have a cluster of multiple machines, and what Hadoop gives is something known as HDFS, Hadoop Distributed File System, which sits on top of all of these machines and is the file system part. It is responsible for giving a unified view of the storages of all of these machines. And it gives you another component called YARN, Y-A-R-N. This is yet another resource negotiator. This is the scheduler part of the big data system. So this is what Hadoop gives you. So the Hadoop distributed file system is an amazing piece of work. So the basic idea is the following. You have a one computer which is called the name node, the one here, and the name node is like the master computer. It is in charge of everything. So whenever you want to work with your storage, you will always talk to name node. Now suppose you say, hey name node, take this 5 terabytes of data and store it on my cluster. What the name node does is that it splits the data into multiple parts and gives various blocks of data to each of these data nodes. And each data node is nothing but an ordinary computer with its own storage. It receives a block and stores it there, and the name node is in charge of, hey, what are the files, what are the blocks they are made up of, and how are these blocks stored on various computers. That's the job of the name node. So this is what very roughly the Hadoop distributed file system looks like. We are not going into details, but just get a feel for it. So the name node is responsible for making sure that the data nodes are always in touch, that the data is distributed equally, that in case one machine goes down, then the block of data has a duplicate copy in another machine so that it can be recovered. So all of this is handled by the name node, and that is what HDFS does. Now when you want to execute a processing job on the cluster, you cannot just about execute any machine, because you see, if you want to do big data processing, remember that I told you data locality is very important. So you need a computing model that is designed to maintain the locality of the data, and that is what MapReduce does. Now there's a historical note here. When Hadoop was first released, there was HDFS and there was MapReduce and nothing else. But Hadoop 2 onwards, what they did is they said, we are going to give you HDFS And we are going to give a yarn whose job is only to schedule, and we'll put MapReduce as something that uses yarn. Now, the reason this is important is earlier in Hadoop, you could only do MapReduce and nothing else, but the modern Hadoop, because of this splitting of MapReduce to yarn and MapReduce, allows other computational models to also be executed. This was very revolutionary in the historical evolution of Hadoop. Not sure if you can appreciate it, but a very important point. So what exactly is this MapReduce? So let's look at this diagram carefully. This is what MapReduce is all about. So here is your data, right? This is the input data. Now, thanks to HDFS, this data has been split and put on 3 computers, right? So you can think of this as computer 1. This is the second computer, and this is the third computer. So these are 3 separate computers or cluster members, and each has received 1 fraction of the total input data thanks to HDFS. Now, when you want to process the data, you must define 2 functions. One function is the map function, the other is the reduce function. The map function has to be designed in such a way that it can work on its part of the data. I repeat, the map function has to be designed in such a way that it can work on its share of the data without bothering about what happens to the other parts of the data. All right, so this machine, right, will take this data and process it. This machine will take this data and process it. This machine will take this data and process it without talking to each other. Now, what is hoped is that the map will be the most intense part of the processing. So without transferring any data across the network, you have done one major part of your processing. Now, there are 2 other phases. There is combine and partition, whose job is to synchronize the data. So part of the result is sitting on one machine, part of the result is sitting on another machine. Somebody has to unite this data together. For example, in this diagram, you would notice that the data marked as A is sitting on the second and the third computer. So what combine is doing is that it is combining all the A's together, all the B's together, all the C components together, X's together. And partitioning is now, okay, somebody has to process this data further, right? So that also has to be distributed. So that is what partitioning does. So combining collates the data parts together. Partitioning redistributes them across the machines, and the final data result is what reduce does. So you see that reduce now gives you one coherent output. This is very roughly what MapReduce architecture looks like. So once again, MapReduce is made of 2 parts, map and reduce. Map's job is that it should take the data sitting on that machine and work independently on that data. And the job of reduce is to finally present the combined result. So very simple way to understand MapReduce is the famous word counting problem. So imagine that you had a text file which was made up of words, right? Deer, bear, river, car, river, deer, car, bear. This is the input. Your task is that you want to count how many times each word appears. Okay? Your job is to count how many times each word appears. So the first step is that you will store the data in HDFS and it will do splitting. So you see that one part is received here, another part is received here on a second computer, another part is received here on a third computer. Now what happens is that we write a map function which says I am going to count each word as 1. So map says, hey, deer I see once, bear I see once, river I see once. That's the job of map. So you see that the map was able to do its job without referring to or bothering to what is happening on the other computers. Similarly, this guy says, oh, car 1 again, river 1 again. And then this guy says, oh, deer once, car once, bear once. So that's it. Map has worked independently on each machine. The machines did not even have to talk to each other. That's the specialty of the map function. Now shuffling happens, right? So he says, okay, all bears come here, all car entries come here, all deer entries come here, all river entries come here. Then the shuffling, that's the combining process. Then the shuffling process says, hey bear, most of you is sitting on computer 1. So computer 1, you do reduce on this fellow. Oh, car, most of you is sitting on computer 2. You process the car part. And therefore it shuffles the data in the most optimal way across the machines. Now we have a reduce function. What does the reduce function do? A reduce function in this case is simple. The map function merely assigned 1, 1, 1, but the reduce function will say I'm going to take all bears, sum up and produce 2. So this reduce will say I'm going to sum up this and produce 3 and so on. And then we have the final result where we say bear comes twice, car comes thrice, deer comes twice, river comes twice. That is how MapReduce works. This is not intuitive or easy to understand. So I'll have to move on, but feel free to revisit this part of the lecture again and again and try to refine your understanding of what MapReduce does. But you see, the reason MapReduce is important is because you see, it is by splitting your computing into a mapping and reducing phase, you are achieving this data locality. So most of the data processing happens on the same computer where that data is stored. That is the advantage of the map function. So data transfer is minimum, and reducing, yes, there is a little bit of data transfer between the computers, but it's very little compared to the kind of data transfer that would happen on a HPC with a network attached storage, for example. So this is the MapReduce word counting process. So summary, MapReduce is a way of writing programs where you design a map function which acts on every block independently. We have a shuffle combination phase, and we have a reduce which produces the final output from individual map outputs. And all processing jobs in Hadoop therefore must be written as a series of MapReduce pipelines. So you do one MapReduce followed by another MapReduce followed by another MapReduce, and that is how your entire logic has to be broken down. And as you can imagine, it is not easy to take something you know already how to write a program for and convert it into map and reduce. It takes some thinking, which is why big data programming requires some training, and people who are good at it get paid bucket loads of money to be MapReduce developers. And it is also true, if you're wondering, can I almost do everything with MapReduce? The answer is no, it is not flexible. There are many things that you would like to do in programming which cannot be broken down into MapReduce easily. So it's not flexible. And that is why we need to move beyond MapReduce. But that is the fourth part of the talk. So we'll again pause here for a while and discuss and then move on.